Okay, so we were talking network diagrams. So who would like to remind me what a network diagram is? Luke.
It's a diagram where it shows lines between different points, and it can be, say, for example, like distances between different cities.
Yeah. Or if it's not distances, it was sushi. Time.
As in this case.
Okay. So we had network diagrams where we had time between 2 points. Now, do you remember how we decided that a longer line does not necessarily mean a longer time?
Yes.
Okay. So we had this diagram which was about baking a cake, no? And the tasks were preheating the oven, weighing out the mixture, mixing the mixture, baking the cake, washing the dishes, washing the cake tin afterwards, and they had to be done in certain orders. Some could happen at the same time though. Alright? So, we went through in two directions, if you remember. Alright? So, we went this way first. So, the top numbers were what? Do you remember? Leah?
They were like the time that it took to complete the task. Okay.
There's got to be a sort of a word in front of the time, or the something time.
Is it like the maximum float time?
We're not up to float time yet, actually. Oh.
Is it the critical time?
No, not critical time.
The quickest?
Was
no,
it
not the shortest, sorry.
No.
Oh,
Archie?
it's the things you have to do before you can do the other
That's
things.
not what the times are. So, the fastest finishing time, is that what it was?
No.
Sushi?
Earliest possible start time?
The earliest possible start time.
Of course.
Good. So, what we were saying was that B happens. C can only start after B has happened, and the earliest possible time it can start is after 3 minutes, because B takes 3 minutes. C takes 5 minutes, so D can only happen after that. So why is it not an 8 there, Archie?
Because you do B and C whilst A is happening,
Okay.
and because A is the longest and has to be done before you can bake the cake, it just...
Yeah, so the fact that B and C are only add up to 8, the earliest possible start time is actually linked to the longest. Okay? And then once C has been, or A has been done, D can be started. D takes 20 minutes, 35, before F can start. Now that happens after 37 minutes. Okay, so it can be finished after 37 minutes. Okay, because 20 and 2 are more than the 8. Right, so we had that. Now we went back the other way to work out what.
Oh, to find the float time, so you were subtracting it by the number, the time.
But the float time happens because we have worked out. So these, if these times are earliest possible start times, the other ones are there.
The latest.
The latest possible start times, and we can work that out because, well, we want efficiency. So this is 37. We don't want it to start any later because that's when it can be finished by. So we just want to know, is there any leeway within our route for when something has to start? Because obviously, if at the beginning I have to wait longer for the oven to heat up than it takes me to weigh and mix the ingredients, well, I can take my time over that. It only takes 3 minutes, but I could take 10 minutes if I want to. So this is what we're working out. What's the flow? So we go back the other way and say, right, 37, this takes 2 minutes. So this is still 35. Okay, this is still 35. Has to be done by 35 minutes for the next phase to happen to finish by 37. Has to. There's no other option. Okay? Now, this one, because this takes 20 minutes, we've still got to have this started after 15 minutes for this to be done by 30. This E for 8 minutes doesn't affect anything. Okay? That just has to happen at whatever time. Yeah? Now there is a float time for E, is there not? Yeah? So actually, E does not need to be started, but because we start after C, we don't really worry about it. Okay? Now here was where you all, I remember last lesson, you were like, oh right, that's what it means. Why, if that's a 3, is this a 10? Is it?
Because if you take the 5 off the 15, you can, it's 50, you've got 10 minutes.
Yeah, exactly. So the 15 up here was worked out using that 15, but actually C can be started as late as 10 minutes and still be done by the time A is finished. Okay, so we're looking through that. So this is what we would call, okay, our critical path analysis. So we've got latest possible start times and earliest possible start times. So we know, you know, what we can work out. Okay, so we'll say the critical path is ADF. ADF. Because that is what really decides the time. So we go, A is the longest, gives me that number, then D, then F. Okay, so that is the critical path. That's the one that determines the entire length. You cannot make it any quicker because of those 3 tasks. Okay. E, there is a float of 14 minutes. We see that because 15 to 37 is actually how long?
22 minutes.
22 minutes, and we only need 8 of those, so we've got a float of 14 minutes. Use the term is a 22-minute. There's no float time for tasks on the critical path. You'll see that. Critical path, no float time. Alright? Okay, so this is a very simple network diagram. Right? If you have a look at example 2, alright, on page 21, right? No, you're not. It's just annoying when people share. Okay. Because he can do it at his own pace and so can you. You can still talk. Right, example 2, it's a more complex diagram. And you'll see the solution underneath on how they work out the values. Okay? So I would like you to read through that example, make the diagram, alright, and fill it in, because that will then help you with your next piece of homework as well. Okay? Makes sense? So have a read through. If there's a problem, we can go through it as well. Alright? Basically, on this network diagram, alright, you were saying it does go left to right, so this is your starting point, so it should have a 0 in there. That's no option. Okay? And then each one of these, if we're doing our critical path, you've got split into 2, okay, and we're going to try and find earliest and latest times for each thing to happen. Right, so clearly the last one to happen is this one, isn't it?
Yeah.
Okay.
Very right, very bottom.
But it goes A, C, D, E, F, G,
Yeah.
H, I.
But that's the N. That's N.
Oh.
Okay. So, obviously, first 2 are nice and easy. So you should have put a 2 and a 4. The next one, B, takes 3 minutes, so this has to be 5. D, K. This one we need to think, because it's got 2 roots coming into it. So 2, 3, 5, 2 would make 7, or 4 makes 8. So it's 8. We have to put earliest possible start time. Okay? Now that obviously affects. So F is only 1, so that's 7.
I'm so sorry.
Can we just?
Can we copy this down? Meant to.
That's what we do.
People like say maybe.
And then we've got this one to. Now this one has 3 roots that we've got to consider. So we go from 8 to 8 could be 16. 5 8 would make
13.
13. 7 7 would make 14. So it's the 16 one we have to say. So 16. So we're saying that all of these jobs, A through to I, can be done in 16 minutes at the earliest. Okay? So, which path are we identifying as the critical path? Sushi?
ABF?
No.
No.
Pardon?
CDA.
C, D, H we think is the critical because that makes the 16. So that's our critical path. So we know that actually our return times for that path has got to be 16, 8, 4, 0. Okay. So those ones are set. The other ones, however, will they have a float time?
Yeah.
No, some of them.
Some of them, not all of them.
They could all have.
Yeah, they should.
But like if you do them like one could have like you could choose which one has a float time.
So for instance, let's have a look. So we're going backwards. This takes 7 minutes.
So 9.
So that could be a 9. Okay, so we have a float time of 2 minutes for that one. Okay. So let's have a look at these lines, this one first. So that takes 8 minutes. So that could be 8.
But then
That would make 7. So which one do we put in?
7.
8.
Put the 8 for like the
7.
latest.
7.
Which one do you think? 7 or 8? Because it's got to be, remember, what are the red numbers? They are the crystal. Remember, it's either earliest or latest, so it's going to be the latest possible start time. So, but the thing is, if I put an 8, right?
Oh no, 7.
Well, hang on. If I put an 8,
I said 7.
this one would not be done in time. If I took 8 minutes, this one would not be done in time. Okay? So actually, this has to be done by 7 minutes. Alright? So we've got the 2 routes to consider. This has to be done in 7 minutes. It's the latest possible time I can start it if that's going to be done by 9. Okay? What about this one? Does that not affect it?
Oh, so no, but then
It needs to be 5 now. It needs to be 5 because then that's 3. You have to take away the 3. That has to equal 2.
No, well, no, this doesn't say this. When can this have been started and everything else still happen? So this is critical. 8. So this really, to get this done, if I don't start that, if that isn't done till 7 minutes, that affects this. That would make 9, and we're not allowed that. So actually, this one can't be 7. It must be 6. It has to be, even though these two suggest something else.
Couldn't it be 7? But then the 2 one would have to be out. You would have to do it in 2 minutes.
So this has to be done after 8 minutes. It has to be.
Oh yeah.
So this has to be 6 to 8,
Yeah.
right? Because if I say that could be done after 6 minutes, that would make this would be waiting for it till 9, and then that would extend the time. So this has to be a 6, doesn't it? Which means this, though, could be done in 3 minutes. Okay.
This is quite interesting.
Yeah, it's like something I've never done before.
So let's just check. Let's check their solution.
Yeah.
So they've got these numbers. We're happy with that. And then, see, there's the critical path that we had. They're the ones that decided. So we've got 3, 6. We were right there eventually. Okay. 9. We're sorted. Yeah. Right. So actually, I'm glad you're saying it's interesting. It's something that people in businesses have to do, right? It's not just kind of when you say, "Oh, when am I ever going to do?" Right? If you're planning an event, that could be a party, okay? It could be the production of the new iPhone, you know, things like that. Anything along those lines. Their events change. So if you're doing a party, it might be, right, so when have I got to have started cooking the main course? Right? Anyone watch British TV? Come dine with me.
Yeah.
Right? How often do they start by they stick the meat in the oven and then they get on with their dessert? So actually the dessert is made. Or even they start with the dessert because the dessert has to go in the fridge.
Yeah, it needs a lot of cooling.
So it needs to be set. So you have to do that first. Okay?
Yeah, that's what
And then you could preheat the oven. But actually you don't need to preheat the oven. So they've got a float on that. So they wait until the dessert is done before. So there's all that planning. The Great British Bake Off, definitely. They have a real limited time. They have to be efficient. Okay? So I've seen it before. Like, oh, I've forgotten to put the oven on, and it messes up completely. Yeah? And then they're trying to cook things, and you know. So, Master Chef, yeah, anything that has a real limited amount of time. What you might be used to having, though, is an infinite number of time to do anything, or just plenty of time. So you've got homework, for instance. Imagine you have so much homework to be done. Now, the trouble with your homework is what?
It's not that much. I mean,
Well, no, I'm not thinking that. I'm thinking the fact that.
That it could take. There's not like a specific number of time that it has to.
Well, also, I'm thinking more the problem is how do you do art while you're doing maths? You know, you can't. You know, unless you have to do something, let it dry. You know, and instead of painting and going, right, I'm going to do the background painting and I need to wait for that to dry for half an hour. You just sit there, watch a bit of TV. You know, you could be doing your English essay while that's drying. But really, you don't tend to have that problem, do you? You just have to do your English, then you have to do your maths. And then, so your network diagram for something like homework would just be a straight line of circles, one after the other.
I could have used it in India.
Yeah?
I could have used this in India.
In India, you have to do one thing with one hand, another thing with that hand. Yeah.
Not only homework, also you get projects which you have to complete by the weekend.
Okay. Well, there you go. So, what I'm going to get you to do then, right? There are more examples. So, if you have a look yourself now, example 3, that'll give you a real good idea for your homework.
Oh,
Right? Same kind of diagram, isn't it? You have a go with example 3. The answer's there. Okay?
That's really weird. That is like a lady.